Hey everybody, we are live. This is the JungleBus workshop live from the South Florida Bitcoin Citadel. I am your host, Kurt Wookert Jr., streaming for the first time in front of an audience and with no producer, eyes all on me. If you're in the house, you can navigate to the South Florida Citadel YouTube channel to watch the slideshow and stream live if you can't see it well on the TVs. Which I guess that one just turned off. Are we streaming here? All right, everything looks pretty good. Can anybody confirm with headphones that you can hear me? Can somebody in the audience, can somebody in the troll box? We're good? Audio's good? All right, cool. Okay. So since it is a first time, it will probably have some technical difficulties. So please bear with. If you're watching live from not anywhere, feel free to put the did that make any sense? That was the worst sentence ever. Feel free to put questions, comments, blessings, cursings, grapes, gripes, or gropes here in the troll box as I speak, as Luke speaks. This is primarily going to be me and Luke giving a presentation. I'm going to give kind of the basics for anybody watching. First of all, if you want this slide deck after, please just send me a DM. I can send you the slide deck so you can read through it. And also, I'm going to give sort of a fundamentals background, why JungleBus, why Bitcoin, why BSV, why all this other stuff. And then we are going to transition to, okay, how JungleBus, how can I use it in my app? And that's what I'm going to hand off to Luke. So we'll have some kind of a transition here right in the middle. When it's time for me to pass to Luke, and we have to switch computers and all that too. But otherwise, we should be in a pretty good spot. Just so you know, Luke, when it's time for you to go, I'll take my computer. You can plug the mic into your computer. It should just swap. But if it doesn't, that's life. We're gonna make it work. So, what are we doing? We have a live film crew, so we might have a little bit of a AV. Are we good, John? Maybe. It's cool. Throw a microphone up. We're good. All right. So, JungleBus. Welcome to the JungleBus workshop, everybody. In a very basic sense, Bitcoin is indeed the most misunderstood communication technology in a generation. But this is actually pretty common. This sort of thing has happened before. With the internet, you had a lot of people trying to redefine what is this for? Whose is it? Does this belong to the Air Force? Does it belong to the Department of Defense? Does it belong to the universities? Does it belong to the people? And for about 15 or 20 years, there's a lot of people doing a lot of infighting as they try to define what the internet stack is. And still to this day, we have intranets, we have the dark web, and we have what we think of as the public internet. But truly, it is very much geographically firewalled in many ways, too. So if you're in China, for example, you get a very different internet than if you're in Seattle, Cincinnati. What's a CH? I'm from a CH city, Chicago, but it sounds a little different than China. So if you are on your way, feel free to come out. We're streaming live from Delray Beach as we speak. Truly, Bitcoin is the internet as a proxy, but it is also a value network. It is a payments network. So consider the internet, but instead of packets going from one server to another via internet rails, packets can be sent via Bitcoin transactions. And that gives us lots of opportunity. So like I said, we don't need to sit and read through this deck. I'm not going to be that guy to sit and read a deck to a crowd of people, both in person and online. But this is worth reading. So what is Bitcoin? In a very basic sense, it's a value network. Nodes connect to one another over a peer-to-peer network, and they send data, transaction data, to each other. So you fill various mempools on nodes, and then with proof of work, you mine the blocks. Whoever mines the block first gets the block reward plus whatever fees are in that block. And in a very basic sense, that is Bitcoin. Now, who are the users? The users of the network also form a separate peer-to-peer network. So wallets can interact with each other peer-to-peer. The most basic way that people have decided to send transactions is I'm wallet user one, and I'm going to broadcast a transaction to the network. The network is listening to this giant set of public key hashes. And if it lands in the public pay to public key hash of the recipient and it gets scanned for and it says, you've received money. And that's the way that almost every blockchain network is bootstrapped today. This is how people are experiencing Bitcoin. And it's super inefficient, especially for payments and especially at scale. So the other way that you can do it is you can have a wallet send directly from Alice to Bob or Bob to Alice, and the recipient broadcasts the transaction to check for double spends. That is a much more scalable way to function, and it's a whole bunch of what we're doing in the BSV economy and working on having the user network be peer-to-peer, as well as the current mining network exists as a peer-to-peer network. And every other Bitcoin implementation, every other network, they seem to muddy the waters between who the peers are in the peer-to-peer network, because we know that in some ways the wallets are, and in other ways the nodes are, and there's a lot of confusion there. It makes sense to think of them as different layers of a mandala network, which, if you're not a computer scientist, is probably also confusing. So what is Bitcoin and why? Like, what is Bitcoin solving for? Bitcoin solves for the double spend problem, also called the Byzantine generals problem. But how does it do that, and why does it need to do that? Well, if you look at Visa as an example, as a payments network, when you send a transaction, you have to see, is this transaction valid? Will it settle? Did the person have the money? If it was a debit card, for example, do they have the money to settle? If it was a credit card, do they have the credit line available for the recipient to actually get that money and settle? In a centralized network, that's very easy to account for, because if you fail, somebody at Visa can just go in and swap it around. That's real easy. The difficulty is with a distributed consensus. So if there is no central controller of the validity of a transaction at the network level, then you have to have some other way to do this. And this has actually been a problem that we're working on in computer science since the 1970s. There has been a lot of cryptocurrencies. Bitcoin is just the most successful decentralized payments network, but is way, way, way not the first. In Bitcoin, the way this problem is solved is with proof of work. Well, proof of work is an attestation of provable loss of opportunity. Well, what does that mean? So in a basic sense, proof of work is, I don't open the door for every person who knocks, but I will open the door if you knock exactly 50,000 times. Well, who's going to do that, right? Well, if you really, really needed to get my attention, you might knock on my door 50,000 times if that was the predicate requirement for me to open my door. So if it was really important, really valuable, say like a Bitcoin transaction, you'll do it. But if you do it once, then you realize I should probably figure out a better way to do this. Perhaps I will create a machine that will knock on the door exactly 50,000 times and a lot faster than I can do it with my two hands. And so this is where the economic opportunity to be more efficient works its way into Bitcoin. Bitcoin has a difficulty adjustment that changes as more people come in and compete. And it's that competitive nature of Bitcoin that keeps it secure. It is not just the code. Many people will tell you it's just code, it's just math, bro. And in some ways, Bitcoin is just code, but truly it is a broader economic opportunity. It's an economic game. It is incentives and economics and human, basically everything that makes us human. And it's attempted to be expressed in code, but it is not code itself. The code is the vehicle. It's kind of like the body is just a vehicle for the soul, for example. Is Kurt just this meat bag that is Kurt, or is there something else in me that makes me also Kurt? Can you divide them? And the answer, I would say, is probably no, but we won't know until I leave this mortal coil. But Bitcoin is much the same way, in that it is a bigger idea, and we're trying to express it in code. We're trying to express it in competitive economics. And what that does is the game that we're playing is the thing that secures the network. And why? Why do we do this? Well, if and this isn't a readable version of the white paper, but the opening line after the abstract is commerce on the internet. And Satoshi Nakamoto explains the problem of centralized payments, saying that the fees involved create a rung that is too high in his opinion. So he is trying to bootstrap a cash system where micropayments fuel the new economy. In fact, the closing of the opening line, or the opening paragraph of the white paper, he explains small casual transactions. That's the goal. He believed in the power of small casual transactions. Well, the problem is that most people see the scarcity aspect of Bitcoin, and they see it as nothing but an investment opportunity, to the point where the most popular narrative about Bitcoin globally is that it's savings technology. It's just something designed to be scarce and to be provably attestable to its scarcity for the sake of, I got more Bitcoins than you, therefore I'm some kind of a aristocrat and some technocratic nightmare, the way that I see it. You can't get my coins, bro, so I'm the king of the world. And that's a very scary and bleak version of reality, the way I see it. For me, when I think of micropayments and the way that Satoshi Nakamoto was very clearly criticizing the expense of centralized payment rails, was because, first of all, there's about 4 billion people on Earth that live on less than $1 a day. And so very small payments, in a very practical sense, just mean food, water, and basic necessities for about half the planet. But then there's also this ability to bootstrap all kinds of other things with Bitcoin. And that can be everything from simple OAuth for a website, or it can be tokens of identity or ownership of other assets globally. And all of that is awesome. I've gone the wrong way. So Bitcoin mining, in a basic sense, by the way, I'm the CEO of Gorilla Pool. Gorilla Pool is the sponsor of this event. Also, many thanks to Bitcoin Association and the other people who have made this possible here at the Citadel. But what we're doing is we're broadcasting transactions to the network. The nodes gather those transactions. ASICs find the hash for proof of work. Whoever finds that proof of work first builds the block. They get the block reward and all those fees. And then the reconciled block is proposed with proof of work to be added to the chain of blocks. If the other nodes agree that it is a valid block and that it's good for the network to move on from it, you build upon that block. It's beautiful. It's a very simple competitive system that secures Bitcoin. Now, there's a lot of drama about what is a node and what is a miner and what is a pool and what are all these other things. And if you start to get these things wrong, these are fundamentals about Bitcoin. And if you think about these things incorrectly, it'll lead you down a path of thinking second, third, fourth, fifth order effects that are also wrong about Bitcoin. And then you bootstrap the entire system in a way that doesn't actually create any value for anybody unless you just got early in the Ponzi scheme. I remember back in the day, people used to joke that, oh, Bitcoin's just a Ponzi scheme connected to a payments network. And then somebody made a follow-up meme around 2017, and they said, and then the really brilliant people, they just got rid of the payments network. so it's just a Ponzi scheme. And this is what started the blockchain, or the block size wars and all this stuff. This is why there's a big blocker version of Bitcoin. This is why there's a BSV, where the people that said, hey, you know what? Maybe the price doesn't matter in the short term at all. Maybe it's what you can build with it. Maybe it's the economic value that can be created and extracted from the exterior economy because of the existence of Bitcoin. Maybe there's something special there that isn't inherently apparent in the network itself. And so, if you look at what nodes do, you can have listening nodes, edge nodes, light nodes. You can call them various things, but there are nodes that don't build blocks. They just simply listen to the network and they can attest to data. Then you have a mining pool. A quote unquote full node, the way I see it, is a node that is fully validating, has the full UTXO set, and also builds blocks. It's something that can write to the blockchain. The reason for this is Section 5 explains what a node does, and Satoshi Nakamoto is very clear in multiple points in Section 5 that you're not a node unless you build blocks. And so there's essentially a dictionary definition for the rules of the network as to what a node is. Then you can also have pools, which are, maybe you run an ASIC hashing machine and you don't have nearly enough hash power to build a block yourself. And so you collectivize with other people that are in a situation similar to yours. And a pool operator basically creates a funnel that you can all put your hash power. We build blocks together, and then you get those Bitcoins relative to your contribution to the pool. So if you're 1% of the pool, you get 1% of the rewards over time. And this allows people to be competitive by cooperating, which is really what Bitcoin's supposed to be about. Now let's talk about data. the block size debate really was about keeping Bitcoin very small so that everyone could run a fully validating node. But like I said, Satoshi Nakamoto created the difficulty adjustment because he wanted it to be competitive to run a node. He wanted people to be pushed off the network if the network became too difficult to participate in at an infrastructure level. And so it's very funny to see that in order to just get around the economic incentives of the network, they said, you know what, we'll just hard cap this forever. We'll make that the political hill to die on. And then you have BTC, which is that. And then you have BSV, which is the antithesis of that, which is we should just let economic incentives rule at every layer of the network's competitive advantages and disadvantages, frankly. For better or worse, we all compete. But why? Why do we want bigger blocks? Why do we want more bandwidth on a network? And I would say it's the same reason why someone might want fiber optic internet instead of dial-up. Does anybody remember, putting the AOL disk in their computer and saying, "Hey, I'm gonna try to get on this internet thing," and what's there? What are the things that are there? Well, at first it was simple relationships. For me, it was using AOL Instant Messenger, hopping in eWorld forums on Mac, and saying, "Oh my gosh, I actually have a friend that doesn't live within walking distance of me." For a kid that was born in the mid '80s, that was massive. That I could talk in a group with my friends at 10 o'clock at night in a way that was silent. I didn't have to sit on my corded phone in my kitchen with my parents listening to me talk about whatever stupid thing I was talking about. But there's a brilliance to the power of communication. And what Bitcoin is Bitcoin is just economic communication. And it allows you to put a value to every bit or byte of data that goes across the network. And so here's some statistics about what's actually going on in the world. This is how much data actually exists. 1 trillion megabytes of data are created every day. This is everything. This is email, this is video uploads, this is your YouTubes and your Facebooks and your Twitters, and trillion megabytes of data today. Data is the most valuable thing in the world. It's also the most undervalued thing in the world over time. So not only is it the most valuable thing right now, it's also the most undervalued. And it is the only commodity in the history of the world that's ever been that way. And so you look at it and say, interesting, the more data we have, the more valuable it becomes. It is the antithesis of the scarcity of other things. Oh, there's only so much oil in the world. There's only so much, whatever, drinkable water or some of these other things. There's only so much gold. And gold, therefore, would get more valuable as it would get more scarce. But data gets more valuable as it becomes more ubiquitous. It gets more valuable as you reduce its friction for use. And so imagine if you could reduce the friction of using data globally by allowing you to put a value at even the smallest amount of data. So we all know that most of the most valuable companies in the world are valuable because they're scraping your data and selling it to 3-letter government agencies or selling it to advertising agencies whose names you don't know. And they're doing all this data aggregation. And you realize that you are sort of like a piece of cattle living on a plantation that you don't really understand. You'd have no practical way to measure your value, but somebody else is becoming one of the richest people in the world or the richest entities in the world by selling your data. You don't have any way to benefit from it because ultimately, you're the kind of person that's got 600 followers on Twitter and, you don't own a big business that anybody's interested in. And maybe your data is worth $50 a year, but that's your $50, or at least some of it is. They helped you monetize it. It's valuable because they exist, but you're entering into an economic relationship with all of these other players on the internet, but you don't have a way to see where it's going, to stop it from going places where you don't want it to go, and you don't have a way to monetize it for yourself before Bitcoin. Well, Bitcoin also, from an implementation standpoint, really struggles in many regards. And the struggle is the fact that the blockchain is just a giant bucket of unsorted data. It's true. This is why the BTC people want you to run your own node, because they want you to sit and validate your own transactions. Craig Wright and I were having a conversation over text when I was in Oslo, Norway last year. And we were talking about the nature of the Byzantine generals problem, because this is what people do in their time off if they're Bitcoin people. But we're talking about the Byzantine generals problem. Proof of work solves the Byzantine generals problem. You can trust somebody that's willing to burn energy to attest to the truth. But he said something to me that initially I had never thought of, but is super profound. If everybody is supposed to be a validator on the network, there's no reason for proof of work. You're replacing the Byzantine generals problem and you're creating a Byzantine soldiers problem. They're saying, hey, we can't trust the generals. We can only trust ourselves. We can only trust each other. And so each of us becomes a mercenary only. You become this island unto yourself, which obviously appeals to the sort of anarchist ethos of every man for himself, and we're all an alpha male or whatever. But I in some ways, I see the romanticism of that in some regards. But ultimately, it creates all kinds of new problems that Bitcoin actually was invented to solve in the first place. The Byzantine soldiers problem is a new computer science problem to solve. And for it, we have gotten rid of all of that opportunity to monetize that trillion megabytes of data a day that we could be monetizing if Bitcoin was allowed to scale, if it was competitively fighting to monetize all that data and to give basically the power of your data back. And so that monolithic blockchain data in BSV, for example, BSV is it's one of the biggest blockchains by total terabytes of data on that chain. Because we don't arbitrarily throttle that data, there's a lot of data to download if you want to run a fully validating node. And we don't want to run a fully validating, I mean, some people want to run a fully validating node, but at some point you just can't unless you're building blocks. You have to have an economic incentive to make a profit on keeping that data set, or else you just won't keep that data set. Why would you do that? Why would you burn money forever? That doesn't make any sense. And so at scale, there really will only be a few mining nodes. People will laugh and say, BSV's only got 15 nodes or 70 nodes or 150. It depends how you measure them. And I always say that's too many. It could be 7. It could be 12. There's just not a reason for there to be fully validating nodes all over the earth. It just creates edges and extra latency and extra problems. But there is a problem to solve. And the new problem to solve is, even now it's 8 terabytes of data is the total BSV blockchain, which sounds terrifying to a blockchain person, but it's literally nothing to anybody else in fintech. Might as well be a rounding error in the amount of data that exists, even just on an hourly basis going through Amazon web servers. And so how do we filter? What is that logic? How do we get that bucket of mixed nonsense data that is on BSV? Every block's got JPEGs or audio files or hashes of other things or simple payments. You got tokens, you have various scripts that are running and doing all kinds of unique things, but there's no logic to it because Bitcoin is asynchronous. There isn't, okay, this next block will be all the JPEGs and the block after will be all your payments. It's not like that. It's just buckets of aggregate data of whatever's going on in the network every time a block is mined. And so JungleBus is this solution. So as a mining pool, we're running some of the most powerful nodes in the history of Bitcoin. They're in data centers. They're very highly connected. We're talking 10 gigabit connections, so we can push network data up and down as quickly as possible. Because when we mine a big block, we want people to accept our blocks and build on them quickly. We don't want some network latency issue to stop us from winning the next block, or we don't want to risk being orphaned. And so connectivity becomes a bigger issue along with data. So a good friend of mine and a longtime colleague, Luke Rowanaz, you would know him from many places, but he helped create some of these tools in Bitcoin about 4 or 5 years ago, actually, that helped solve a bunch of these problems of indexing and parsing and, okay, what data do I actually need? How do we want to interact? What if we leave a subsection of things for use for just social communication or just transferring data or just participating in subsets of social things, the way that we're kind of trained to by people who use Twitter or other applications. But a lot of these things had scaling problems because, well, Bitcoin had a bunch of scaling problems. We have a ton of dependencies in the node software because it's been developed unprofessionally and in a total scattershot manner since 2009. And there's a lot of bugginess across all of the blockchain space because soft forks and all these things create interdependencies that are very, very complicated to solve. So Luke and I came up with just conceptually some of these ideas. What should an API look like that is connected to Bitcoin? How should people be able to filter for their data? How can a startup who's been told, hey man, you can build apps on Bitcoin, how do they start their business without having to download the full node client, which is already pretty impractical today? Doesn't work very well. We've seen a few companies in the space, we've seen, frankly, dozens of companies in the space say, yeah, we're not supposed to download the full client, but how else are we going to get our data? And then they download the client and they spend so much time being an infrastructure manager of their own system instead of focusing on application development. If you're not focusing on your app and your business, you're screwed. If you have to hire a high-level sysadmin, that's a $150,000 a year job if you want it done consistently well. That's a cost. And you've got no way to recoup the cost just for managing the node. And it's the same thing where I want to start an internet business, I guess I need to buy a Comcast node and I need to, that's just not how people do business today on the internet. And so JungleBus is essentially a piece of middleware that allows you to bootstrap an overlay network of just your data. So maybe you're a token, let's say you're an NFT minting platform, and that's all you do. And you only need your company's or client's NFT data. How many megabytes is that? Out of the terabytes of data that are on BSV, well, how much do you actually need? It might only be a gig or two. That's your company's data, but you have no practical way to extract and use that data unless you build a tool that does it. But how do you attest that it's real? How can you promise your customers that this is a completely valid token? How do you solve the back to Genesis problem? How do you prove that this isn't some problem? You don't have any proof of work to show. There is no digital attestation of the purity of the token you're giving them. This could be a right-clicked JPEG. Maybe the one that you bought is actually gone. Somebody else stole it, but because you only have a client-side attestation, they have to trust you that it's valid. That kind of sucks, especially if your thing is very valuable. It might not matter so much if we're talking about a 5 cent or a 50 cent or a $50 token, but it really starts to matter as those values go up. Maybe you're holding a $6 million hash that is an attestation of ownership of a priceless piece of art that has been attested to by Sotheby's and Christie's. How do you know somebody didn't right-click it and send you a different hash? How are you validating that? Well, you can't. A miner must validate that information for you. There must be all the cryptography of the network. You got your Merkle trees and your stuff, and you need the proof of work attestation. You need to basically ask a company like Gorilla Pool and say, is this actually my token? Is this actually the thing that I own? Especially if it's changed hands. Maybe it's changed hands 1 million times. Well, that's a lot of hashes to index, especially if you don't know how, especially if you're trying to focus on your business. So what JungleBus does is it gives you an interface where you can filter for that kind of information and you can ask immediately. It's basically a gateway. Instead of having to call our ops guy, hey, is this token real and whatever else, you can subscribe to it using JungleBus. And the more that you do that, the more that you can use the API in JungleBus to create other applications where these problems are just solved for you. You don't need to run a node. Instead of running $1,000 a month infrastructure, you can run $50 a month infrastructure, and you just subscribe to just your client's data or just your company's data or just the things that matter to you, because we have done the work already of mining the data and then filtering for it and then giving you very simple logic that you can run and test against our filters. And then you can run your data set on your system and you can say it was attested to via JungleBus, via Gorilla Pool, we're good. So if this is wrong, you can go yell at Gorilla Pool, because they're the people that have mined it, attested to it, they're serving it to us, or they've served it into our database. And at scale, this allows people to create a new network. You can see at the end here, there's a mesh network called Metanet that is essentially an overlay network that sits atop Bitcoin, that is all this higher level application data that can all interact very nicely and simply with each other. And so Metanet, well, there's a proper Metanet protocol that was created by Nchain and some other people. And then there's more Metanet, the lowercase m, that is this sort of internet of value that can be bootstrapped. It's this ability to actually send data through Bitcoin transactions and have those transactions be valid without you having to validate them. And so JungleBus really should be the thing that sits behind this deeply industrial, infrastructural, confusing company. You know, when you drive by AT&T buildings in every town and they look like an NSA building, well, partially it's because they probably are, but but they're running stuff. If you were to walk into that building and see the way that those networking switches and all that stuff, it's crazy. You don't participate in that to run your website. You don't even know. You don't know what it looks like. You just know that it works. That's the kind of company that Gorilla Pool is and will increasingly be at scale. And what JungleBus is a little bit like, it's like the little piece of hardware that you would hand out and say, here, this is your access to the internet. So it's not a perfect analogy for a couple of reasons, but in a basic sense, you call Comcast or AT&T or Verizon and say, hey, I want to be on the internet. They say, cool, take a half a day, you'll be up online, you can just use the internet. That's the world that we're trying to create here with JungleBus. It is an essential piece of technology. So here's a basic graph that kind of explains ways that you can use it. You can use it just for very simple things. You run your own servers, you do your own stuff. All of it is just Web 2, basic internet stuff. And maybe you have tokens, or maybe you have proof of work, music or whatever that you want to be streaming from the chain. JungleBus allows you to do that, and just that, without having to run your system or run a full node and tax your system. This allows you to get a very cheap DigitalOcean account or whatever and run just your data that has been attested to with proof of work. So it's kind of like, I'm not going to make another analogy. So in a basic sense, that's how JungleBus works and what it does. We keep trying to get this fully synced. Jungle Run is something that we've been working on for a long time. Luke, this is like your 5-minute warning. We're gonna swap you in a couple minutes here. But the other thing that JungleBus does is, because we've done a ton of research and development into ways to filter and index and process data in ways that are valuable, we've realized it can also be the guts of existing other databases. So other indexers exist. We have quote unquote competitors out there that are doing things in certain ways, but they do them in a very inefficient way. They're doing them the way that you would run a full blockchain node, which is crazy. It just doesn't make sense, because you're still indexing the whole lot of whatever it is that you're doing. The way to do this properly, again, is to use the blockchain data. You're trusting a miner anyways, but what you do is you take the miner data, you filter it through JungleBus. JungleBus replaces, in this instance with Run. RunDB is a very cool tool, but it's inefficient, and you had to trust Run's API. They were running that infrastructure and attesting to the validity of tokens. Instead, it's Gorilla Pool attesting to the validity of the tokens, and you are just passing that data about Run tokens into our engine, and you would use the Jungle Run API instead of the RunDB API. And it's exponentially more scalable, and it is basically direct to the metal. You're getting it direct from a miner instead of from, I mean, no offense, but Brenton's server somewhere. And so it's just it's crucial, again, maybe not for sub-cent tokens and these simple NFT things, but at scale and as values go up, it's going to matter. What's that? SLAs? Yeah. I mean, imagine you have a client that's paying you $25,000 a month to attest to the validity of something that you're selling them. What are you promising them? When you're promising, well, I don't know, Run sends us this API. It's like, okay, well, has it been passed to somebody 1 million times? How long does it take to prove that this is actually the one that was minted 20 years ago and that I'm holding that token. Oh, it's going to take us 3 weeks or whatever to go through that database. JungleBus solves all that. You can literally just ping it and say, hey, is this the one that was minted here and has been passed all the way to there? And we can tell you instantly, and for pretty cheap. A lot cheaper than running your own index, I'll tell you that much. So we can do this with all kinds of other things. I don't, my microphone is very directional. I don't think I can even hear you. So, making coffee. Also, free espresso for the time being at the South Florida Citadel. And bananas, free bananas every day. So, so what does that allow you to do? Well, it allows you to do a lot of things. It's actually kind of similar to the way that the tokenized agent works. A lot of people say tokenized is the most scalable token protocol. And the reason for it is that they work as an agent for their own token validation. And so you can trust their API that your thing is what it is. Well, that's kind of like trusting run servers to do the same thing. They're running their own index. Wouldn't it be better if it was a proof of work attestation of validity on a token? And this is what we've created. So JungleBus can be the guts of your STAS token API or anything. You got a JPEG business, got an NFT company that's selling music on chain. Do you have are you selling physical items on the blockchain directly? Maybe you want to create a streaming service. Maybe you've got some business idea that has all kinds of data intensive application, but you can't bootstrap it because you can't afford to run your full node. We've seen things like this. There is a very popular game that has created tons and tons of transactions that really struggle to figure out their business model because of the necessity for running their own quote unquote full node. These are the problems we're trying to solve. I want you to be able to start your company for $10. If you have a really killer business idea, I want you to say, I don't need to raise 50 grand to go spin up a node and hire a sysadmin and all this other stuff. I want you to say, I can go to junglebus.gorillapool.io. I can create a filter. I can have this done for $5 and I can start my business on Bitcoin, accepting payments. The rest of our roadmap, which is to be announced, includes everything from wallet infrastructure, how you manage all of your UTXOs. It's all done pretty poorly right now too, but everything from UTXO management, how you get data into your node, broadcast in, how do you get it mined efficiently? And then once it's been mined efficiently, how do you get that data back out? And once the data is out efficiently, we're also creating all kinds of logic for how to build applications such that they interoperate with each other the way that we assume they do on the internet. That also took a lot of work, like decades of arguing between people for, hey, how should we all just be able to universally send emails or texts or JPEGs or social media data? And requires a lot of infrastructural planning. We've been doing that planning. JungleBus is a critical step. The reason we're putting JungleBus out first, it allows you to build applications. And the answer for how will come from Mr. Luke Rohanaz. I may have added a little too many syllables to that, but this is maybe in spicy. But Luke, if you want to come up, we can swap microphones and stuff here. Everybody, please bear with us as we make the swap here. As we make the swap, I see a couple of. Thank you, everyone. Gal, who's been a good friend and an ally, is Jungle Run a drop-in solution for the Run API? It will be when we're done syncing. It's not quite ready yet, but essentially you can use Jungle Run's infrastructure as a complete replacement for whatever you're doing with Run tokens. Who do we got here? This is great. Otherwise, I'm going to set up my own database and reference ID to confirm on Bitcoin. Awesome. Glad to hear it. Let's see if we got any other quick and easy ones here as we. Okay, good. Just good feedback from people. So thanks everybody. Please bear with for a moment as we swap Luke in. I'm gonna disappear for 30 seconds. So don't disappear on me. We'll be right back. give me
Mic check 1, 2. You got me? All right, coming through. Cool.
Go ahead and can you add a share screen? You see a
Yep.
share option? No?
Cool. You seen it?
I think we're good. Everybody, show a little bit of audience and stuff here. Sorry if we didn't get doxed. Please like, subscribe, hit the alert bell. We're also trying to fill up the Software Bitcoin Citadel streaming channel. We're going to do monthly workshops and then also social events. There's going to be something going on here every week. So if you like, subscribe, hit the alert bell, it helps us with our YouTube channel. Also, if you can share this content, let them know that you're watching live. Add questions to the troll box here. I'll be answering and pushing questions onto Luke once he's done with his basic presentation. And then when Luke is doing more help for people that are in-house, we're probably just going to end the stream. A little bit of motivation for you to be here in person next time. And Luke, I'm going to pass to you. So thank you.
All right, very good. Cool. Well, that was a good high-level overview and some background of why this even exists in the first place. And I'm going to get into a little bit more detail about what it's actually doing, what you can use it for, what you can't really use it for, what it's not as well suited, because there's a lot of common kind of theme to what people try to do with it versus what it's really designed for, and just kind of get into a little bit more specifics here. So the first thing to really know about JungleBus is what we're doing is you've got a miner. They're already looking at every transaction. So this isn't, some extra overhead for them or something like that. As the transactions are coming through, they're basically seeing, hey, is there some data or is there a data component to this transaction? It goes off to this side process where it's getting evaluated and kind of inspected. And we're figuring out what types of outputs are in it. And we have a collection of known protocols that are supported by the service at the moment. And if it finds any of these kind of this data inside the transactions, they're being tagged, put into a large database, and then and this is a very it's a big database, but it's a scalable one. It uses Cassandra under the hood, which, if anybody's familiar with that, this is a database system specifically designed to scale horizontally. So as things get pretty full, you just add another Cassandra node, and we'll continue to scale horizontally with more hardware as Bitcoin grows. Now, to kind of a little bit touch back on what Kurt started with here, the purpose of this is to be able to listen to the blockchain in a scalable way. There's lots of people you see will always criticize scanning the blockchain, saying anybody who's doing any blockchain scanning is doing it wrong and you shouldn't be doing this. And I think this is a little bit of a shame. It's a little bit short-sighted because I completely agree. Most times, you don't need to be scanning the blockchain for any reason. You definitely don't need to be running a full node and then scanning everything in it to find what you need. More times than not, you're going to have a better time having your application that's doing whatever with Bitcoin transactions, send it to your backend API. Your backend API can broadcast those transactions off to the network and then keep its own local fast and accessible copy of what's going on in your app. Where JungleBus is really shining, though, is with cross-platform interoperability. This is not something that you can do if you're not paying attention to the activity that's happening on the blockchain. This is what everybody who tells you, never scan the blockchain, that's not exactly what we're doing. I'll explain the difference. But anybody who's telling you that is missing this giant use case, which I think solves a whole bunch of problems in society. So basically what JungleBus is doing here is we're filtering the blockchain and creating very minimal indexes that you can then tap into in order to get a feed of just that little sliver of data from the blockchain instead of having to get the whole thing in order to get what you're interested in. And, I'll start, I guess, by looking at, I guess let's start here on the JungleBus website. So this is the website. I'm already signed in here. So if I go to the dashboard, this gives me an overview of the data that I've used, right? But if I go to subscriptions, you see all these different subscription lines here. The one I'm using for the demo today is this map subscription. And all this is doing is looking for a protocol called Magic Attribute Protocol. And it has a special output type that we tag on the ingestion of this data called map. And this subscription is very simple. You can see the form. I just give it a name, a description. The output type of map is what I'm interested in. And then you see some demo code here that's provided that will get you started to actually create your application, to create your indexer. Now, this is an important differentiation. What we're creating here is an indexer that is then going to power your app. It's the backend or the API for your application is what you should be building with JungleBus. You're not connecting JungleBus directly to your app. And one important thing to note here, this subscription ID that you get when you create a new subscription with JungleBus, this is a like per application, per connection subscription ID. You're supposed to have one of these running at one time. This is why you don't run it in your front end, because then everybody visiting your website is using this subscription ID to connect to JungleBus. You have multiple active connections. Not supposed to do that. It's supposed to be one connection from JungleBus to your indexer, and all of your clients visiting your website hit your API, which has a cached copy of all the data that it got from JungleBus. And I'll dig into this a little bit more. I'm going to show an indexer that I created specifically for holding this map data, and then it's able to do a little bit more, and you're able to query it with way more flexibility than you can query JungleBus. Now, going back to how do you query JungleBus? Well, this is basically it. You get this form, and you are able to put in a few things, and then depending on what you get here, you'll have a feed of just that slice of the blockchain. So one thing that you could do here is addresses. Anytime we encounter addresses in the transaction, whether they're in inputs, outputs, or whether they're in like author identity protocol signatures, for example, which is in the data section, most block explorers and things like that won't pick up those addresses. It doesn't even know that there's addresses in there, just knows there's some data. That's kind of the value add of JungleBus here, is it's doing the deep inspection on the transactions, tagging everything that it finds, and making it so that you could search for just these things. So for example, somebody is using an identity system like Bitcoin attestation protocol, and you get some identity address that's being used to sign transactions. Well, technically go in here, put that in the addresses section, and have a feed of all of the data related to that individual that was using social media across 100 different websites or something like that. So let's switch gears a little bit, because this doesn't explain which of these output types, what do you put in for context, what do you put in for subcontext. So we'll go over to the JungleBus documentation here. And oh, they don't need to. They just have my screen up. Yeah.
I just pushed it.
Oh, okay, gotcha. Okay, cool. So here we're looking at the JungleBus docs that goes over, the entire service here, and we've added the details about the protocol. So the supported output types right now out of the gate are AIP, which is Author Identity Protocol, B, which is a protocol that Unwriter made long ago for storing any type of file on the blockchain. BAP is Bitcoin Attestation Protocol. This is for signing any data that you put into a transaction with your identity keys. This is how you can have a portable, persistent identity across many platforms and have that be completely decoupled from the website. What you're used to seeing now is every single website you go to, you have to put a username, you put a profile picture, probably a bio, something like this. The idea is we have one place where you do that, and then this profile can follow you across all of these different apps. Next output type is Bitcom. Bitcom was another concept that came from the Unwriter Atlantis Slack days. This is basically using any Bitcoin address that you generate with your own keys as a protocol prefix. So if you have your own app that you created your own Bitcom protocol, you can just filter using JungleBus for the entirety of all the data that your app has ever used, and only your app. MAP is Magic Attribute Protocol, which we touched on briefly, and then Run is a token protocol. Now, obviously, we want to add others. So all the big data protocols that are in use out there, not limited to data. We'll be able to do, script based protocols as well. So some of the ones that would be on mind is, other token protocols like tokenized, like STAS, like the protocol that the Twetch team is using for their stuff. Also, script-based protocols like Boost, which is for signaling, like almost upvoting content by transaction ID. All of these will slowly be added and supported here in the future. But this is the set that we have to work with in the beginning. And we'll just kind of go through these quick. So these are in alphabetical order. So AIP protocol, author identity protocol. What this is used for is, let's say you're making we'll center all of this around social media posts. We have a client called BitChat, and BitChat is a place where anybody can go. There's a bunch of channels. It looks like a lot like Discord. This is actually what it looks like right here. And you could type anything in here, and when you do, it's making a Bitcoin transaction under the hood that follows a very specific format. And then it is signing, you see this little lock icon, it's signing the data that gets put in there with my identity key, and this is happening with author identity protocol. So you can see that this is not populating, if we go back to that this subscription field here, what we're talking about, context and subcontext are these fields. Some of these protocols will put additional data in these fields to make it possible for you to filter and search just on those things, but some don't. So that's all described in the docs here. Author identity doesn't put anything in context or subcontext, but it does populate addresses. So if I sign something and there's an address associated with my key that I'm signing with at that time, it will go into the addresses field, meaning I can put that address in here and then I can filter on just that data. Moving forward, B protocol, this is for any type of files. And let's say I wanted just a certain type of media type. Well, we put the media type in the context field in JungleBus. So if you want just PNG images, you could put in your subscription, image/PNG, and then you would put output type of B here. And now you have all PNG images on the blockchain that use B protocol. And you won't be downloading all the other data that's on the blockchain that has nothing to do with files, that has nothing to do with B protocol, or has nothing to do with B protocol images that are not specifically that type. Now you can also specify multiple output types here by using a comma separated list. Okay, next one. BAP protocol. This is the attestation protocol. These are the actual, this is not heavily used in practice at the moment, but Bitcoin attestation protocol exists and it allows people to do real world identity through attestations. If you think about the way your identity works in real life, if you go to the DMV and you're in a new state and they want you to prove who you are so that you can get a license, what do they ask you for? They ask you for a bunch of attestations, essentially. They want electricity bills from a company that they know that is saying that you are this person with this name and you're at this address, and that address has to match the address that you're putting on your license, and they want your, maybe an ID from out of state, or maybe there's like 6 different forms. They need a good amount of reputable attestations in order to establish your identity, and that's how identity works. So what Bitcoin attestation protocol is about, making these attestations and all of that. So what you could do here is, let's say you wanted to make an indexer that was indexing all the activity having to do with your identity. You could go to JungleBus, put in a context of your ID key, your identity key, and then you wouldn't know what this is unless you knew what attestation protocol was and you were using it. But if you know your ID key, you can put that in, and then you want to see all the attestations, you can put attest in the subcontext, and you'll get only that data. You could leave subcontext out, and you'll get more than just attestations. You'll get other types of activity that happens within that protocol. As you can see, we also put any additional stuff in the data field as well. So there, in some cases, there are other things that you can find by doing a filter that uses that as well. Okay, next up, Bitcom. This is people making their own custom protocol prefixes. Pretty straightforward. You just put your protocol prefix in you put Bitcom as the output type, your custom protocol prefix in the context, and you're going to get everything just for your app. Map protocol. Map protocol is magic attribute protocol. This is what we use for tagging arbitrary metadata on transactions. And then we actually use this to form schemas that mean things. So just to show you what I'm talking about when I say that, there's this website called bitcoinschema.org, which defines a few of these initial schemas. And again, we're focused on social schemas today. So let's say we were looking at, a post. In this case, we're actually looking at messages, which are more like chat messages, where posts are more like posting something on your timeline on like a Twitter style thing, where a message is more like a instant messaging app or a Discord type of a thing. So in messages, we can see here, if we want to post in global chat, we post the B protocol prefix followed by the actual content of the message, the media type, which in the message world, this is typically going to be text/plain for a plain text message, or you could do rich messages with text/markdown. And then the encoding is going to be basically be UTF-8 all the time for these types of things. If it was an image, it would be binary or whatever, but for the sake of messages, those are UTF-8. And then we have a pipe character, which is just that's a, let me back up for a second. What we're looking at here is these are the individual push datas that go into a transaction. When a transaction is made, you have a script, you have the op return opcode. These days, we actually do op false and then op return. But what this is signaling to the script interpreter is that there's no other script to be evaluated after this point. After this point, it's all just data. And there's no rules in Bitcoin script about it doesn't even look at that data, it doesn't know anything about it. So all these rules and all these things that we're talking about are external to the actual script processing. In the future, we probably will move some of this stuff or bake some of this stuff directly into script. That can happen as this evolves. But we have a whole way of evaluating data, without it being necessary for it to be a valid script or anything like that. You could just put data in this section. So anyway, in the data section, first we have the message content gets expressed using B protocol. Then we tag it with some extra information using map. So map, the map command is set, which means we're setting keys and values. The two keys that we pretty much always have in map transactions is we have an app name, which is supposed to be the source of the app that is making this message. And then you have an action type. And in this case, the action type is message. This means anybody else can read the blockchain, and if they see, if they filtered, for example, on any type of message, well, now you can get just a list of all messages across all apps, and it's cross-platform, and then you render them. So we'll show you what that looks like in a little bit. And then we have another pipe, and then we have the AIP protocol, which is the signature. So this is the user makes a post. You have the post content. You have some metadata that says, hey, it came from this app, and this is a message type of post. And then you have a signature that signs all of that data. Now, there's some other variations of a message. You could do a message in a specific channel, which is basically the same. You just notice it adds the context of channel, and then the channel is going to be whatever channel name you're posting into. And a lot of people, when they do this, they think that they can just drop the context channel. Oh, that's not necessary. We don't need context channel. You'll see why this is so important. If you do it the way that the spec says, you can interoperate with all the other sites. But more importantly, when you're doing the filter, you can do things like query for all messages that have a context of channel. This means you don't care about which particular channel it is. You want to build an indexer that has all the messages in all the channels. Well, you can filter on, show me where a transaction has a map context of channel. And then we even have a separate scheme for doing private messaging. And I won't get too much into that, but you can do encrypted cross-platform DMs using this scheme as well, which is really, really crazy. I don't think there's anything else out there that even does this that I'm aware of, to be honest. Cool. So a lot of a lot of background out of the way there, and hopefully this is explaining the low level like data structure, what we're talking about when we go back to the docs here and we finish talking about the different protocols that are supported here. So when you're in the JungleBus subscription, you would say the output type is map, and then if you wanted just a particular app, it takes the map.app value, which we just saw is the name of the site. So for Jamify, for example, we use a map.app value of jamify.xyz. So if I was doing a subscription that I just wanted Jamify content, I could do map, and then context could be jamify.xyz. And now my subscription will give me all just Jamify stuff, right? Cool. And then there's actually in the data value, we're actually putting the individual keys and stuff, so there is more opportunity to search them. So, all right, cool. Now we've got a subscription created here, and now that you know what all those fields mean and the supported protocols, this is essentially what the code looks like to get up and running with the subscription. And just to kind of go over this here, what's happening in this code? What is this? Well, the library that we have out there that allows you to easily communicate with JungleBus is made for use with Node.js. We do have a Go version of the client available as well on the Gorilla Pool GitHub org. But if you were to just do like a yarn add or an npm install Gorilla Pool /JS JungleBus, you get this installed in your project, and then you can import the JungleBus client, and then this is the types for the control message, because this is I believe that's the types. Yeah, because the library is actually in TypeScript. I don't think that's used here in this example. Let's see if I'm crazy. Oh yeah, it is right there. Okay. But yeah, these are not really too important to the point. But so here we go, creating a new client using the JungleBus endpoint. It could be imagined that other miners might run a similar service in the future. Maybe you would connect to a different miner, or maybe JungleBus has multiple regions, and you might put in a different URL here to connect to a region that's closer to your indexer or something like that. And you're gonna start getting callbacks when you do this. You'll get a callback when the connection is connected, when it's connecting, and when it's disconnected, and when there's errors detected, so that you can do different logic, gracefully close your database or restart your app, or whatever you might need to do given your use case. And then we'll get into these. This piece here is actually really important. So here's what's actually firing up the subscription. So it is subscribing. It's using this identifier, which you find up above here. When you create this subscription, you get this subscription ID. In your code, you just put the subscription ID in this place. This is the starting block height that it'll begin syncing from. So if this is an app that you just created, or a new spec that hasn't been around very long, you want to sync from the most recent block possible, so you're not downloading a whole bunch of data or doing a bunch of requests that are going to return no data. And then you got all these callbacks for different things. We have on publish, on status, on error, and on mempool. So on publish is the callback that happens when there's a transaction that's been published. And what this means in JungleBus language is this is something that was actually found in a block. So a block was found, this transaction existed in that block, and you're going to get a callback for every single transaction that exists that was found inside of a block. On status is just status messages having to do with which block you're on, because remember, you're getting a feed of transaction after transaction, right? Now, one transaction might be the last transaction in a block. Well, you'll get the unpublished for that last transaction in the block. Then you'll get a block done on status callback to let you know that block is actually complete. So if in your logic you need to keep track of which blocks are synchronized and which ones are not, we have callbacks that actually tell you about that. And also some callbacks in here that are important for things like reorgs, so that you can rewind and re-index data if there is a reorg that happens, so you can make sure that you're up to sync with the latest chain tip on Bitcoin. So that's on publish. That has to do with a block. On status, on error is pretty obvious. If there's any error for any reason, you're going to get a callback there. And then on mempool means a new transaction was seen by JungleBus that is not yet in a block, but it does exist in mempool. So this is what you're going to use for all the real-time stuff. You know, if you want something that is reacting instantly as soon as it's broadcast by some other application, you're going to see that in the on mempool callback. So we'll switch over to some real-life code here and show you kind of what this looks like in the bmap indexer. So the first thing we'll show here is that b.map.sv. This is an indexer that was originally built to use bitbus and the planaria stuff that was out there from Unwriter long ago, and was modified to just point to JungleBus instead of bitbus. And most of the code that was there indexing all of these transactions is able to stay the same. So it's pretty cool for people who did invest into a lot of this stuff in the early days. And what it does is it gives you this GUI that lets you kind of explore the data that's in the data set, but it also gives you this other endpoint here, which lets you basically take this whole query language called BigQuery and query my index. So we're not scanning the blockchain for this data. We're just querying this little basically shard that was created by JungleBus. So all we did was say, hey, give me a JungleBus subscription that just is map data. Then we created an indexer that's going to pull that pipe of data that comes from JungleBus and do even further inspection on that data and do things like maybe resolve BAP IDs that are associated with users that were signing things, maybe some extra enrichment of that data, and then we save it into this database. And what that does is, even though JungleBus is super limited, you're not going to be able to query every single field in map. You're not going to be able to, you know, sort things in different ways or do other more advanced queries. You can, when you build your own indexer, you query all sorts of ways and can do real fine-tuned queries on that level. But the purpose of the JungleBus connection was to get that first data set to be dramatically smaller than what you would need to do if you're running a node or trying to actually scan the whole blockchain. So I just basically went to the same URL here with a Q instead of the word query. They're the same otherwise. The query brings you to this GUI where you can check it out. And the Q is actually what you would use in your app. And we'll show you more of how that works now. So switching over to the code for that API that I just showed. Here's the bmap API. And you can see it's got a crawler process that gets kicked off. And when the crawler process starts, what it does is uses my map subscription here. It then reacts to on-publish messages. There's actually some changes that could be made here because we've improved the library a little bit. You don't need to set timeout anymore. So let's get rid of that. This can just be async await, actually. Either. That's a lot cleaner. And cool. So whenever something's found in a block, it calls my process transaction function. Same thing that's happening down here on mempool. So both of those goes into this process transaction function. Now in here, I'm taking the raw transaction that it gives me, which is the most compact representation of the transaction. It's actually transmitting that, just side note, in binary from JungleBus to the client. It uses centrifuge under the hood. And this actually means, even compared to like bitbus, the amount of data that actually needs to go from the JungleBus service to your indexer is like half of what it was before. So we've really optimized that. Now it enriches the block attribute. So what we're doing is we're basically building up this object that we're going to put into a Mongo database that's going to be easy for us to search. And we're enriching the data with some of the extras that JungleBus provides, like the block height, the time that it was seen, and if it doesn't have a block time here because it's not actually in a block. If this was a mempool thing, then we actually just tag it with whatever the current time is on the indexer. It also provides a Merkle proof as well, which is pretty handy in some cases. Cool. So that's pretty simple. It just goes over that, and then it's using one other piece. So call save tx here.
Can you see the question on screen?
No, I'd have to switch to the screen. What's the question?
The question is there a callback for a TX for which the initial block was included, has been orphaned, and is now in a different block?
Not exactly, but you get a callback on the reorg, and then you're still going to get those on publishes after that, and they'll be in order. So you would have to construct your logic in a way that makes sense. Or and most of the time in reorgs, all of the transactions are going to end up coming back through anyway. So you'll end up getting an unpublish of like the same transaction that you already processed, which you can just reprocess it and overwrite the original that you stored already in your database with the new one. So yeah, you have to do a little engineering to kind of like to get that all to go perfectly smooth. But
Client side logic?
Yeah, or in indexer side, it's not, client side is a whole nother hop away. But on your indexer, yeah, you would put some logic in there to handle that. But yeah, all the important pieces like the actual callbacks for the events that are happening allow you to hook into those events and then trigger whatever code you need to based on those things. Okay, so then just quickly in this transform piece, so what we're doing here is we've got a transaction parser, and this is called bmap.js. I'll show you a couple of things related to this. So bmapjs.com is kind of a nice little microsite that shows you a bunch of example transactions and lets you explore kind of what those look like. So you get a raw transaction in, and then it splits this stuff out into this nice object. In this case, it's showing us that we've got some B protocol stuff in this transaction as well as BitVic. And the bmap indexer is basically just taking raw transactions, using this parser. It's actually using the Go version of this parser, not the JavaScript one here. But it's parsing this stuff and then creating an object like this to store in Mongo, which then lets us search on it. And I'll show you what that looks like in a minute. There was one other thing I wanted to show you. Even a lot of us use What's on Chain as a block explorer. And it's pretty neat that they actually have, as you're looking through any particular block, actually, let me get a valid map transaction from here if I can. Let's do this. I'm just looking for any transaction that has a transaction hash, which they all do. I think I'm just not outputting it here. Should work. Maybe not. Okay. Well, apparently I don't know what I'm doing, so we'll skip that for now. But basically, on What's on Chain, if you're looking at any particular block or a transaction, here's a my 2 cents one. This will work. So if I went to this transaction, you see some bmap data here. This bmap tab over here. This is using the same parser as bmap.js, and what it's doing is just telling you what's inside the transaction from a data standpoint. And you can see my 2 cents using their own protocol. They're not following the Bitcom standard where that would be an address, but you can see it broke out the data related to the my 2 cents protocol separately, and you can see the string value, the binary value, et cetera, et cetera. It's not the greatest example for this, but I'm just showing you that it's easy to check on this, that this tab does exist on What's on Chain, and that's really handy. Okay, backing up. So we've got our indexer. We're processing raw transactions as they come in. We're detecting all sorts of different protocols that might be on them, making this nice object, and then we're going ahead and saving these. We're doing some extra steps here for BAP IDs, actually looking up some more information using another API. But this is kind of what you can do. You can get like a sliver of data, bring it in, and then enrich that data as it's being processed, and then store it in your database. And then out the other end, you get an indexer that allows you to do these really flexible queries. So let's skip right to the indexer exists. It's up there. It's live. What does it look like to have an app that actually uses this thing? So here's BitChat. This is the test channel in BitChat. This is bitchatnitro.com. If you see over here on the left, there's a handful of other clients that will interoperate with this website because they're listening to the blockchain for the same type of data. Now, okay, what's like a way that they would listen to the blockchain? So there's a couple ways, but there's really not a whole lot of people that are doing this. JungleBus is this tool designed for exactly this use case. So another client could have their own indexer also listening to JungleBus for activity based on it could be just anything with type of message, for example, and you're only interested in the chat messages. You're not interested in posts or anything else. So there's Josh right here in real time posting as we're testing here. So he did this. If you see off to the right, there's this little heart. This came from Retrofeed. It didn't come from BitChat. He was able to post from his own client, and you're seeing in real time this getting updated on this app. Well, how is this really working under the hood? Well, what's happening is here is the output from the live indexer that I just showed you the code for, and you're seeing that JungleBus is hitting callbacks on mempool events. So and then you're also seeing that there's clients connected to BitChat, and it's pushing real-time WebSocket data down to everybody who's visiting the website and giving them, hey, there's a new message that just showed up in this channel. So every time that anybody posts on any platform anywhere, as long as they're following the spec, I'll get a call back to my indexer that this data occurred, and then the clients using it will get a message that something happened here. So you can see different users on the website right now getting real-time data sent down to them and mempool transactions coming in from JungleBus. So pretty cool stuff. We got a few people chatting in here. Hey guys. And this is creating a Bitcoin transaction. It is creating it in a format that complies with all of this, and that's pretty funny. When ordinals, of course. Give a little laugh emoji on that guy. Let's check out the code of what it looks like to actually write one of these things on chain here. So here is some BitChat code, and here's the section where it's actually this is not the right section. It's here. Here's where it's actually sending a message. So it's starting by creating this data payload. And like I said, this all happens because we're putting data in the op return section of a transaction. Something that I might add, most blockchains can't do. The ones who have recently discovered that they can do this are going to discover that their blockchain can actually handle it. So BTC recently started doing ordinals. Now, ordinals are not sticking data in op return. It's a little bit different because they're sticking the stuff in the witness data. They have a very different structure. They have tight limits on op return, so you wouldn't be able to do this type of stuff there. So what they're using is kind of a workaround to stick data somewhere else where it's not really designed to go, and then reading the data out on the other side. The problem there, I think this is the site, mempool.space, is that it? Yeah, so the problem there is you could see because people started putting this data on chain, we've now got a backlog of over 70 blocks waiting to get put into the blockchain. Now, if this was on BSV, these 70 blocks total up, a little over 200 megabytes. We have 200 megabyte blocks all the time. This would be processed in the next block, and the mempool would be completely clear. On other blockchains, they're not designed to handle data. They don't scale with big blocks. And so the stuff is really not possible and not scalable elsewhere. Just side note there. So all we're doing here is we are putting this data payload on chain. And you see it's an array. And what this is Bitcoin has push data when you're doing script. If you ever looked at a raw Bitcoin script, you see it's like, if we pull back up what's on chain here, we can see, just go to any transaction and you'll see basically, this might be a bad example, but you basically see these commands. So you have opcodes, but then you also have these chunks of script, and they're separated by these spaces. And what this is, these are push data, right? So imagine a script like this. Eventually it hits op return. The Bitcoin nodes don't process anything beyond that. And that's where we're sticking our data, okay? And it's these push data is one at a time, separated. You know, if you're looking at that script viewer, you just see them separated by spaces essentially. But each of these push data has to be in this order to some degree anyway. Map is a bit of an exception there. It doesn't care about the order, it cares about the key value pairs. But so here we go. We do the B prefix, which is this. Hold on. Apparently we're in France.
Alexa, turn the volume down to 1 at the office.
That's funny. I'm not sure how that happened, but it was fun.
It was my fault.
Okay. Kurt's fault, as always. All right, cool. So we got our data payload. First one is the B protocol prefix, which you see that's like an address. That's that Bitcom prefix I was talking about earlier. When Unwriter created B protocol, he created first a protocol prefix for it. And that's what you use to tell JungleBus or whoever's listening to the blockchain, hey, this data coming next is following B protocol. So you can expect the next field will be the actual content of the message. The next field will be the encode, the MIME type, and then the encoding. Then we have the protocol separator. Now we have the map prefix, which is another Bitcom prefix. The command, the app is going to be bitchatnitro.com, and the type is going to be a message. Now we go through, we've already put the message content in there, and it does some extras, like if you're in a channel and you're not in the global channel, it actually puts the channel there. And then if you are, you know, this is still a little bit of a work in progress. As you see, I got to-dos in here and stuff, but the point is, this is for DMs. This is for encrypted stuff so that you can do the handshake to do DMs and stuff like that. But that's essentially it. And then from here, we have different logic branches that depend on just like which wallet are you using? Are you signed in with Handcash or Relay? And you just use the wallet specific code to send out that transaction. In the future, I think this will be more of a universal API for that, and whatever wallet the user has installed will be invoked and actually handle the transaction separately. So that's really all this is doing. It's using either Relay or Handcash in this case to broadcast. And then on the other side, it's making this full round trip. So I'm broadcasting out from the app. I type something in here, hit send. It, let's say it was Relay. Well, Relay broadcasts to whatever nodes Relay is directly connected to. And then those nodes see it first. The mining network, it has a peer-to-peer network between all of the miners. They propagate that transaction across the other nodes. JungleBus hears about it because Gorilla Pool is mining and is updated, pushes out to any subscriptions that are listening for that particular type of data. The indexers all around the world get populated however their particular use case sees fit. And then in our case, there's also a WebSocket subscription from the client on the actual app to the indexer so that the user can have a true real-time experience that this transaction was made, and here's the data. So this is like a good real-world example of exactly how this works, exactly how it's implemented, and how the interoperability really shines. So the reason I want to show this example and not something where I'm just building my own app and I care about my own data is because if you're caring about your own data, there's a whole alternative approach here. That is, you know, you don't need to have something like JungleBus in between, and you can do this very efficiently where you just have your application, a user makes the transaction the same way in the front end right here, and instead of broadcasting that directly with your wallet, you would send it to, you might still do that, but you would also send the transaction, the raw transaction itself, directly to your backend API. Your backend API now has that transaction. Anybody using your app is populating your API, and you're not listening for the rest of the universe of the world of like who's making similar messages that I care about. JungleBus is really for that use case of where you want to listen for other platforms doing the same type of thing to get this really cool interoperability that you can get by using Bitcoin as a shared backend. So yeah, I think that's a good place for the tech demo. I don't know if you got any questions lined up or anything over there, Kurt, but I think we're moving on to that phase here.
Yeah, here's Adam asking, would it be very useful to have NFTs in our operation with this? Like, suppose a Satoshi stored avatar, VRM, and some 3D metaverse app with chat bridge to bit chat.
Totally.
Maybe what are some other, what else can we interconnect? So like right now, I'll go back here and do this.
I love this question.
So I'm right here. So to Adam's point, how many things are operating? There's people in bit chat right now that are talking due to this conversation. And then there's also, what does this look like at scale? What does this look like in 5 years if things take off the way that you want them to take off? This sort of de-siloing of everything situation.
All right, I can't wait to answer this. This is the fun part. So there's tons of stuff. I mean, it gets really exciting when you start thinking about it, because so here's some ideas for apps that I've had over the past few years of doing this. I mean, when I first published Magic Attribute Protocol, I mentioned some of these use cases that I still haven't got around to like building. But you know, it's a big blue open sea of opportunity for anybody who wants to build really cool interoperable apps here. We actually have a hackathon that we're going to be doing at the end of March. Details to come soon on that. But I'm really excited about that because we're going to really put this to the test and see what kind of cool ideas people come out with. But here's a couple really good examples that I've given in the past. One is, imagine you're in the supermarket and you have an app and you just scan a UPC code of anything. Well, the UPC code could be this global identifier that you're referencing. So you remember we have the context here of a channel, and we're chatting with the context of a channel, and we're in the test channel, and you can see other people with test channels. Well, what happens when the context is a Bitcoin transaction ID? Well, that's how we do replies, right? So we'll actually show another app here. This is, oh, looks like there's an update here. That's good. This is another website that interoperates with BitChat. This is Blockpost. And if you look just kind of at the homepage here, you're going to see data from a bunch of different apps. Including some stuff you can see. It's picking up some Twitch stuff, but these are people have encryption turned on, so obviously there's nothing to see. We could switch this to just be, I pressed the wrong thing. But the point here is with posts, we saw message type, and that's what BitChat uses. Blockpost is using, I'm looking for something with a reply. I'm actually not seeing one with oh, here we go. This one has a reply. So here you go. Here's a post that actually has a reply. This is something that has the context of another transaction ID.
Class.
So now, oh, nice. So imagine you could have a context of anything. So I used to have an app called MetaLens. And what MetaLens did was it let you chat with the context of another URL. So this was a browser extension that as you're browsing the internet, I actually still have it right here. I don't think it will work though. No, okay. You could post, instead of the context of a channel, you could have context URL, and then the URL be any web page. Now what this does is it lets us have almost like Discuss, you know, that commenting platform that you find embedded in a lot of web pages. You basically have an open chat system or a commenting system for every website, whether or not that website is sanctioning or embedding or like including that. It's like a global repository for that stuff that's external to the actual website itself. Another one is, imagine you're in a store, you have an app that has a barcode reader, you scan a can of Pepsi, and now you can see all of the comments that everybody's made about this particular product. And that stuff is not in some database somewhere where an executive is going to say, oh, we don't want that information getting out there. Let's make sure these comments don't surface on our website or whatever. This is not something that is controlled. It's something that is a collaborative data set based on everybody who's using this stuff. Now you can imagine in the future that might get a little messy, right? So people could post anything in there, right? They could put a bunch of junk in there, and just muddy up this the Pepsi response with a bunch of just random gibberish or something like that, and that would kind of, you know, defeat the purpose. Well, there's two things here. One is, it's not like the existing internet where you pay nothing for these posts. They're Bitcoin transactions, so you have to pay something at least out of your wallet in order to put them on chain. BSV prices are extremely low, but this is in early days. As Bitcoin scales massively, a Satoshi will be worth something. And you know, a few hundred Satoshis or whatever it might cost to post this data on chain would be a sufficient deterrent for like overt spam. Now, there's another thing where we have identities, right? In the future, I would imagine I would only really care about listening to comments from people who have identities and have signatures on their posts, you know, because you can kind of establish a history. You can even weight different things using kind of like web of trust type systems where, well, if there's somebody I'm following, I'm going to care more about their opinion on things versus somebody who I'm not following. And all of these types of systems can still be built very similar to like what we have on social media now. So even though that this does get a little chaotic and a little messy because it is permissionless, anybody can just write stuff to the chain in any way. The people who are really good at extracting the value, keeping the data clean, and giving users options to see just what they're interested in will thrive in this kind of ecosystem. This whole paradigm is totally different. It actually encourages all of the applications that build on this technology to be super competitive on user experience. This is brand new. Most people are competitive now on network effect. You know, Facebook gets a giant network effect of billions of users or whatever it is, and they don't have to, they don't really have to bend to the will of their users as much. They can make controversial privacy changes. They can do things that kind of piss people off, and they're still not going to lose that many users because, you know, that's where everybody is. That's where your cousins and grandma and high school friends and everybody is. So how do you compete with that? Well, in the current paradigm, you don't. But the idea here is that maybe we can. Maybe we could band together with thousands of these websites that all use Bitcoin as a common database. The users own their data truly. It's totally portable to where somebody can just log out and log into a different client if they get censored or banned or anything like that. So yeah, it solves a whole bunch of problems that we have with the current set of things. Getting back to ideas of what we can do with this, another one of my favorites, something I'm probably going to spend some time on really soon, is we can geohash stuff as well. So we can take a comment and we can do a context of a geohash, and then the geohash is this location. And now I've got a comment that's literally physically pinned to this room, to where now you can build an AR app that looks around the room and can see messages that were made in this spot. And then not only that, but you could see them over time, because everything in Bitcoin is time-stamped. So you could have a time scrubber that goes from like the beginning of time and scroll through, or like play it like an animation, and you would see in your little AR app, you bring up your phone, you're looking around the room, and you're watching comments pop up and then disappear over time, because you're replaying the history of the blockchain and seeing, hey, this person said this at this time, this person said this at this time, but it's overlaid on top of the real world. You could do not just comments that way. You could do pictures, you could do 3D models, you could do all sorts of really cool things with putting the content that we use all the time, comments, posts, images, NFTs, pictures, well, pictures are images, but you get the idea. 3D images, what I meant to say. All of that can be overlaid on top of the real world. And there's just like so many different cool things that you can do with that foundation. I mean, if you think about video games, which I often do, because I think the design that goes into building really good games, and some of the concepts of making that stuff very accessible and very fun has been really like rigorously like vetted. You know, one game after another, these people dump, you know, tens of millions of dollars into developing these games, and they are all about trying to figure out what is keeping the people's attention longest, what is easiest for them to use, what mechanics do they like, what do they not like, and all this kind of stuff. And one of the things that I think has been massively successful in video games is the idea of a persistent shared world. People really, really love this. This is what made World of Warcraft huge. This is what makes Pokemon Go huge. This idea that the world around us is overlaid with the internet, and that, or in World of Warcraft, it's a little different. It's a complete virtual world that has no mapping, right, to the real world. But imagine you had a World of Warcraft type of idea, but it's mapped one-to-one to the real world as well. There's just a lot of really neat things that can emerge from that. And that sense of a persistent shared world that I can touch and I can have an impact on. I can put something here, and 10 years from now, somebody's gonna be able to see it in that spot. It's really cool, you know. It's kind of an abrupt stop there, but yeah, those are a few of the ideas that you could do with this. But you could do so much more. You know, you'd have to think of it in the lens of any particular industry. You know, you think of it as the people doing like commercial fishing and then selling fish, right? I know we have some of this in BSV. I think the Unisoc guys were focused on this exact kind of thing. But yeah, I mean, to be able to just simply tag things on chain in a standard way that some other company, whole other client, like you could have a big like logistics company that has software that does things a certain way, but unless you get everybody in multiple countries using the same software, it's never really going to fully interoperate. They need some standard to rely on and some way to interchange that data back and forth. And usually there's some kind of a manual process. You have to know, hey, this guy over there has data in a format like this. Let me import it, or let them publish it somewhere that I can rely on that it's there and I can get it. But even that relies on that server that it's being published to being reliable. What if that goes away? Bitcoin is like this permanent middleman that glues all of this stuff together and makes interoperability way more feasible for way more different use cases. Another one is like, think of the way BitTorrent works. You've got people trying to share files, but and I'm not saying that we should be sharing files by putting all of the data on chain, but I'm talking about the discovery of peers and the discovery of who has what data. You know, that's the sort of thing that you might be able to look up on a blockchain, like they use the hash tables that they use. Now the difference, the interesting difference, let's say that using BitTorrent protocol, you had some picture that was being shared between people. Obviously, a picture is a silly use case for BitTorrent. Usually it's for larger files, but let's just use the picture as an example. You have this picture that's on somebody's computer and it's published somewhere. Somebody gets wind of it. They use some magnet URL. It opens in their client, and now they're trying to download this picture. Well, if I'm not seeding the picture and I'm the only one with the picture, you can't download the picture. It's not going to work. You know, you need the people to be seeding. And this was one of the big problems with BitTorrent in general. Like a lot of times you'd find something, maybe you're looking for something that's a little older, not currently popular or whatever. Oh, cool, it's on BitTorrent. You can't actually download it because you couldn't find any seeders that have that file at all. Bitcoin actually gives you the opportunity to give a permanent seed that clients could then always have a connection to. You know, and it also lets us do things with micropayments where we can incentivize seeding directly peer-to-peer as well. So that's kind of a whole different topic. But I want to touch on the permanent seed thing because this is really interesting. Even things like the Wayback Machine could use this type of setup where you're writing Bitcoin, block data to the blockchain in a very specific way. You know, if it's an HTML file, we write it as a B file on chain. And now you're starting to record records from the internet, which is volatile and changes and not time-stamped. You don't get a history of everything that's changed on the internet. You do on Bitcoin. So you could just periodically have a service that's hitting certain websites and archiving that stuff to the blockchain. And now you have a historic record for whatever reason. This is really helpful for things like public records. You want to see what the privacy policy was for a company as it changed over time. You know, Simple Bot could hit the top 100 companies that are out there, hit their privacy policies, save them online, and now you have a really cool archive mechanism. And JungleBus would be a really easy way to retrieve just that data to build a service around that. You know. All right. Any other questions?
Cool, Matt. Yeah. Any other questions from the gallery? Do we have?
You just call us the peanut gallery.
Peanuts? Any peanuts with questions? If not, we've ordered barbecue, ribs, chicken, and sides for anybody that's hungry.
Barbecue's so good.
So we'll be doing that soon. If no questions, nobody else in the out in cyberspace. No.
So is the JungleBus coming, or is the JungleBus here?
The JungleBus is here. It's still in beta. I'm just testing to see if this is cool. It's working great. So posted from blog post shows up here as well. Yeah, it's here. It's in beta. There's no pricing scheme attached to any of this at the moment. Eventually, that is the whole purpose, is that you'll have, to be a paid service. Some people are like, but it will have a generous free tier. And, the good thing about a paid service is it will last. It will be there because, you're buying the service. The money goes into actually maintaining and keeping that up and running and alive. So I think that was one thing that's really missing from data services in Bitcoin so far. And I think getting this to a level of maturity where we can offer like an SLA where, you can be guaranteed that you're going to have your data. We've got a little bit more work to do there with redundancy and multi-region and all that kind of stuff. But when we get to a point of stability where, that's ready, we'll turn that piece on and it'll be ready. But it's absolutely ready for anybody to go to the JungleBus website, which is junglebus.gorillapool.io. And you can get into the dashboard, make a subscription, use this simple node code here, and you'll be off and running and getting data in no time.
Beautiful. Any other questions before we wrap, everybody? All right, I think that's it. Luke, thank you. Can we get a round of applause, everybody? Beautiful. With that, Luke, all right, I bumped you from the stream, so you're good to rock and roll. Everybody, thank you for joining us. This was our first stream here out of the South Florida Bitcoin Citadel. We had a technical difficulty or two, but ultimately I think it was a successful one. So thank you, everybody, for watching. It has been a pleasure. If you could like, subscribe, hit the alert bell so that every time we go live, we will be doing at least monthly workshops here. And late March, we are going to be having a Bitcoin schema hackathon. Dates, times, other stuff to be determined. But let's start thinking last week of March. Make a point to come down to Florida or participate remotely. Have a really good time. We're going to focus on iterating on the stuff that we're building here, and then ultimately doing all kinds of other cool stuff. So if you want to follow on Twitter as well, we're at Bitcoin_Florida. And if anybody has any questions or anything, you can DM. The presentation should go live for rewatch as soon as we're done with broadcast, and then everything else should be great. So everybody, thanks so much for joining us. It has been a lovely morning. And if you're here in person, chicken and ribs are coming any moment here. So everybody, happy Friday. Take care and goodbye.